All right, so here's the tripartite. We've seen these already. Now these are and inequalities too, and so it has to have that intersection. And so use methods we discussed in last section to solve these, basically, is how we're going to do it. So we're just going to simplify and get that k or the p all by itself in the middle. And so whatever we do on this term, we have to do here, and we have to do here. So we're going to subtract 8 in all three cases. So here we have a 3 is less than, k is less than or equal to a 4. Okay. So again, if we draw this, here we have a 4, here we have a 3. So k is greater than 3, so we have open circle. And k is less than or equal to a 4. And so here, the intersection, this isn't going to include both of them because we have to have and both. And so this is going to be a parenthesis 3. Now this one's included in both, so we have the 4, and that would be our solution. And again, we've seen this already. We know that, it's easy to get this here part, and then we know that we also, on these, we don't really always have to draw the graph because we know this one is going to dictate it's a parenthesis, this one's going to dictate it's a bracket, and so we have 3 with a parenthesis on it, and then 4 with a bracket on it, and that's what we end up with looking at the graph. All right, how do we solve this one? Well, it looks like we're going to have to multiply all the pieces by 7. So we're going to have 7 times 1 less than or equal to 7 times p over 7 less than or equal to 0 times 7. All right, well, 7 times 1 is 7 less than or equal to, that cancels, so we have p less than or equal to, well, that's just 0. Okay, so let's write this one down. So let's draw it, because now we have p and, oh, let's put our 0 on 7. I guess we better do that first. P is greater than or equal to 7, all right, and less than or equal to 0. Here's another one. We have to have an intersection, but it doesn't work that way. So this is another one is empty set, so there's no solution. Okay, and so this happens even with tripartites, no solution. And so, that's why, again, it's best to always draw the graph to see what it looks like. All right, here, what do we do? Well, let's see. We have an n minus 9, so let's add 9. All right, so that's going to give us what? Negative 2 less than or equal to n less than or equal to 9 minus 5 is 4. So we have a 4 over here. We have a negative 2 over here. And so n is greater than or equal to a negative 2. Go that way. But n is less than or equal to a 4. Well, the intersection is just between those. So it's going to be a negative 2 to 4. And that will be our solution. Okay. And we'll stop and we'll come back for more.